Seismic monitoring stations across 7 countries detected something that should be impossible. A magnitude 7.6 earthquake just tore through the Philippine Trench, and within 180 seconds, fault lines in Indonesia, Malaysia, Taiwan, Japan, Papua New Guinea, and Australia began moving. Not in hours, not in days, in minutes. Scientists are watching in real time as stress waves race through the Earth's crust at 8 kilometers per second, triggering what tsunami warning centers are calling a cascading failure event. This isn't 7 separate earthquakes. This is one interconnected catastrophe spreading across the Pacific Ring of Fire faster than emergency systems can react. Over 500 million people live within tsunami evacuation zones across these 7 countries. And right now, wave detection buoys are registering something that's never been documented in human history. Multiple tsunami source points activating simultaneously, creating wave interference patterns that could multiply heights to levels no coastal defense was designed to handle. The Philippines just experienced its big one, but here's what's keeping seismologists awake at night. 6 other countries are about to experience theirs, and the waves are already racing toward coastlines where evacuation orders haven't even been issued yet. Is this the preview of a new class of disaster that crosses borders faster than information? And when stress transfer makes every earthquake an international event, how do 500 million people evacuate at the same time? The Philippine archipelago sits at the most violent intersection on the planet. Picture 4 massive tectonic plates colliding beneath the islands in a geological demolition derby that never stops. The Philippine Sea Plate diving eastward, the Pacific Plate shoving west, the Eurasian Plate pressing south, and the Sunda Plate pushing north. This isn't a simple fault line. It's a pressure cooker where continental forces converge with nowhere else to release except through the ground beneath 110 million people. For decades, the pattern was predictable. The Philippines typically records about 100 measurable earthquakes per year, with roughly 20 strong enough to cause damage. The rhythm was almost routine. Tremors every few days, tension releasing gradually, isolated events with regional impacts. Emergency protocols were built around this baseline. One earthquake, one response, one recovery. But 2025 shattered that framework completely. Since January, something fundamental has changed beneath the Philippine seafloor. Seismic monitoring networks are detecting microquake activity that's more than doubled previous yearly averages. In September, a magnitude 6.9 earthquake struck Cebu, killing at least 79 people and sending shockwaves through communities that thought they understood their seismic risk. 10 days later in October, a magnitude 7.4 quake hammered Mindanao, followed within hours by a magnitude 6.9 aftershock. This rare doublet earthquake, 2 major quakes in rapid succession, killed at least 10 people and injured over 1,000. Emergency responders barely had time to assess the first disaster before the second one hit. But here's what the casualty numbers don't show. These aren't isolated incidents anymore. Advanced seismometers operated by the Philippine Institute of Volcanology and Seismology are picking up a pattern that rewrites everything geologists thought they knew about earthquake mechanics. Each major quake isn't just releasing energy locally. It's simultaneously loading stress onto neighboring fault systems in a synchronized sequence that spans international boundaries. The data is undeniable. When the Mindanao earthquake struck, monitoring stations in Indonesia recorded immediate pressure changes along the Sunda megathrust. Within minutes, not hours, Malaysian seismic networks detected activity in fault zones that had been quiet for decades. Taiwan's instruments logged stress variations along the Philippine Sea Plate boundary. Japan's deep ocean sensors picked up preliminary signals in the Nankai Trough, one of the most dangerous subduction zones on Earth. This is what seismologists call Coulomb stress transfer, and it's happening at speeds that make previous events look glacial by comparison. Dr. Renato Solidum at Phivolcs describes it as a mechanical heartbeat pulsing beneath the entire Western Pacific. Each earthquake doesn't end. It redistributes force to the next pressure point, creating a chain reaction that never truly stops. What we're witnessing is stress transfer on a planetary scale, and it's accelerating. When a major earthquake strikes, most people think the danger is over once the shaking stops. That's a deadly misconception. The real threat is what happens in the minutes and hours after, when seismic energy tears through the planet's crust like a shock wave through water. Stress waves travel at 8 kilometers per second. To put that in perspective, that's over 28,000 kilometers per hour, faster than any tsunami, faster than any warning system, faster than any evacuation order. These waves don't just shake the ground, they fundamentally change the stability of fault lines thousands of kilometers away, pushing some closer to failure and pulling others back from the brink. The physics is brutal and precise. When the Philippine Trench ruptures, it doesn't just affect the Philippines. It sends a pulse of mechanical stress radiating outward through the Earth's crust, arriving at distant fault systems before anyone even knows the first quake has happened. We've seen stress transfer before, but never like this. The 1992 Landers earthquake in California triggered aftershocks across multiple U.S. states. The 2012 Indian Ocean magnitude 8.6 created cascading failures affecting fault systems as far away as Japan. The 2004 Sumatra tsunami altered stress patterns across the entire Pacific basin. But what's happening now in 2025 is different in 3 terrifying ways. It's bigger, covering 7 countries simultaneously. It's faster, with transfer happening in minutes instead of days. And it's synchronized, with multiple fault systems responding in a coordinated pattern that suggests they're mechanically linked through stress networks we're only beginning to understand. Modern seismic analysis has revealed something that sounds like science fiction, but is documented in hard data. The Philippines sits at the center of what researchers are now calling a mechanical stress network spanning the Western Pacific. 7 major fault systems are responding to Philippine earthquake activity in real time, like dominoes positioned just close enough that when one tips, the rest follow. The Sunda megathrust in Indonesia, capable of generating magnitude 9.0 earthquakes, is showing a 300% increase in background seismicity. The Manila Trench in the South China Sea, running just 100 kilometers west of Manila, is experiencing dangerous stress accumulation that exceeds historical baselines. Japan's Nankai Trough, which last produced a magnitude 8.0 earthquake in 1946, is displaying preliminary fracture signals in seafloor monitoring data. Taiwan's Philippine sea plate boundary has elevated microquake activity, clustering in patterns that seismologists recognize as pre-rupture behavior. The Banda Sea faults at the Australia-Indonesia border are experiencing stress field changes detected by satellite radar interferometry. Malaysian Peninsula faults, historically considered low risk, are showing unprecedented activity levels that have triggered government reviews of building codes. The New Guinea subduction zone has synchronized pressure variations that align perfectly with Philippine earthquake timing. What makes this revelation truly alarming is the speed of propagation. Previous Coulomb stress transfer events took days or weeks to trigger distant earthquakes. The 2025 patterns are happening in minutes to hours. October 2025 marked the first time in recorded history that 7 countries detected simultaneous seafloor pressure changes from a single earthquake swarm. On November 2nd at 4:23 a.m. local time, tsunami detection buoys from the Philippines to Japan registered synchronized pressure anomalies, not from tsunami waves, but from coordinated seafloor movement. The monitoring data is unprecedented and terrifying. The Philippines has recorded over 847 earthquakes in the past 30 days, compared to a normal average of 8 to 12. Indonesia's Banda Sea is showing a 300% increase in baseline seismicity, with clusters forming along sections of the Sunda megathrust that haven't moved in over a century. Malaysia has recorded its first ever seismic activity in historically quiet zones, triggering emergency meetings between government officials and international disaster response teams. Taiwan's Philippine sea plate boundary is experiencing micro-ruptures that geologists recognize as the kind of incremental failures that precede major slips. Japan's Nankai Trough is showing stress accumulation patterns that mirror conditions before the 1946 earthquake, which killed over 1,300 people. Northern Australia is detecting distant pressure signals using instruments so sensitive they can measure ground movement of less than a millimeter. Papua New Guinea's seismic timing has synchronized with Philippine earthquakes to a degree that suggests direct mechanical coupling through the Earth's crust. When scientists map this activity, a disturbing sequence emerges that reads like a countdown. Within 5 minutes of a major Philippine earthquake, local tsunami, generation begins as seafloor displacement pushes water upward. Within 5 to 15 minutes, stress reaches Indonesian fault systems, with seismometers detecting the arrival of pressure waves that increase rupture probability. Within 15 to 30 minutes, Malaysian peninsula faults respond with micro-quake swarms that indicate stress loading. Within 30 to 60 minutes, Taiwan and southern Japan detect changes in strain meters and tilt meters, monitoring fault movement. Within 1 to 3 hours, the Australian continental margin responds with measurable ground deformation. Within 3 to 6 hours, full Pacific Ring of Fire stress redistribution is complete, creating a new pressure map where faults that were stable are now primed for failure. Dr. Ross Stein from the United States Geological Survey has been studying stress transfer for decades, and even he admits the 2025 events are beyond anything in the scientific literature. We're witnessing earthquake clustering on an international scale. The Philippines isn't just triggering local events. It's mechanically connected to fault systems across the entire Western Pacific. The speed is what terrifies us. What used to take hours is now happening in minutes, creating cascading failures before warning systems can even process the first event. But the earthquakes are only half the threat. When multiple countries experience major seismic events within hours of each other, their tsunamis don't just add up. They multiply through a phenomenon called wave superposition, and the results are catastrophic. The traditional tsunami model is straightforward. One earthquake creates one wave train that radiates outward from the source, losing energy as it spreads across the ocean. Emergency systems are designed around this single source scenario. Detect the earthquake, model the wave, issue warnings, evacuate coastal zones. But what happens when 7 different earthquakes generate 7 different tsunamis within a 3-hour window? The physics is absolutely horrifying. Tsunami waves from different sources can combine through constructive interference, creating amplification zones where wave heights don't just add, they multiply. If the Philippine Trench ruptures with a magnitude 7.6 earthquake, it would generate waves up to 8 meters, high striking coastal areas within 20 minutes. If stress transfer triggers the Sunda megathrust in Indonesia with a magnitude 8.0 event that creates waves up to 15 meters targeting the Java coastline and propagating toward Malaysia and Singapore. If Taiwan's Philippine sea plate boundary ruptures at magnitude 7.0, that adds 5-meter waves sweeping toward southern Japan and eastern China. If Japan's Nankai Trough fails at magnitude 8.2, that generates 12-meter waves hitting Osaka, Nagoya, and Tokyo within 30 minutes. If the Malaysian continental shelf experiences a magnitude 6.5 earthquake, that creates 3-meter waves in the South China Sea. If the Australia-New Guinea boundary ruptures at magnitude 7.5, that sends 6-meter waves toward the Queensland coast. If Papua New Guinea experiences a magnitude 7.0 earthquake, that generates 4-meter waves in the Coral Sea. But these waves wouldn't remain separate. Computer modeling shows they would create interference zones where multiple tsunami sources converge and amplify. The South China Sea would see waves from the Philippines, Malaysia, and Indonesia arriving within minutes of each other, creating combined wave heights of 15 to 20 meters in areas where individual waves would reach only 5 to 8 meters. The Celebes Sea would experience combined Indonesian and Philippine waves, generating interference patterns that could produce rogue tsunami peaks exceeding 25 meters. The Pacific Basin would see Japanese and Philippine waves, creating amplification zones along coastlines from Taiwan to the Mariana Islands. What makes this scenario catastrophic is that current tsunami warning systems are designed for single-source events. When 7 countries generate tsunamis simultaneously, warning networks can't process the complexity fast enough. The technology designed to save lives wasn't built for mechanically connected disasters. Our tsunami warning infrastructure has 4 critical limitations that turn deadly in cascading events. National focus means each country monitors its own fault systems independently with minimal real-time data sharing between nations. Single-source modeling means tsunami simulations assume one earthquake source, calculating wave arrival times and heights from a single point of origin. Communication delays mean international alert systems require minutes to hours to coordinate warnings across borders and languages. Data processing limitations mean current systems cannot handle simultaneous multi-country seismic input without overloading or producing conflicting advisories. The speed problem is the deadliest factor. Stress waves traveling at 8 kilometers per second outpace every human response system. Seismic detection and analysis takes 2 to 3 minutes to process earthquake data and determine magnitude and location. Tsunami modeling requires 5 to 10 minutes to calculate wave arrival times and heights using bathymetric data. International communication needs 10 to 15 minutes for multi-country alerts to be drafted, translated, and distributed. Public warning systems need 15 to 30 minutes for evacuation orders to reach at-risk populations through sirens, text alerts, and emergency broadcasts. When the Philippines triggers a cascading earthquake sequence, affected countries have negative response time. The tsunamis arrive before the warnings. The 2025 wake-up call is brutally clear. Recent monitoring data shows stress transfer events happening faster than our ability to detect and communicate them. We're fighting 21st century disasters with 20th century warning systems. Dr. Katsuichiro Goda from the University of Bristol has dedicated his career to tsunami risk assessment, and his recent statements carry the weight of someone who understands the infrastructure gaps. Cascading earthquake hazards represent an entirely new class of disaster that our current monitoring infrastructure simply cannot handle. We need to completely rethink tsunami warning for the age of stress transfer. Single-nation systems won't work when the disaster crosses 7 borders in under an hour. The infrastructure reality is staggering and getting worse with every earthquake. Over 500 million people live within tsunami evacuation zones across the 7 affected countries. Current evacuation capacity was designed for single-country disasters with hours of warning time. No existing protocols exist for simultaneous multinational evacuations where every coastal road, every inland route, every emergency shelter activates at the same moment. Port closures affect international supply chains instantly, creating secondary economic disasters as shipping lanes shut down and cargo sits stranded. The Philippines' earthquake swarm has revealed a truth that disaster planners can no longer ignore. We live on a mechanically connected planet where earthquakes in one country automatically trigger seismic events in others through stress transfer networks operating faster than human response. The evidence is overwhelming and undeniable. Stress transfer networks are now scientifically documented across the Pacific Ring of Fire. 2025 seismic events are happening 10 times faster than any historical precedent. 7 countries are mechanically linked through crustal stress transfer. Current warning infrastructure cannot handle cascading disasters that cross borders in minutes. Every earthquake in the Philippines now carries the potential to trigger the big one in multiple countries simultaneously. We're not preparing for 7 separate disasters. We're facing one interconnected catastrophe that moves faster than information. The Philippine earthquake swarm continues building pressure across the entire Pacific stress network. Each tremor brings the system closer to synchronized failure. And when it comes, it will redefine our understanding of what a natural disaster can be. The questions are no longer theoretical. They're immediate and life-threatening. When stress transfer makes every earthquake an international event, how do we prepare for disasters that cross borders faster than warning systems can communicate? If the Philippines can trigger Japan's big one in under an hour, what happens to the concept of national disaster preparedness when the threat is regional? And when 500 million people across 7 countries face tsunami threats simultaneously, who gets saved first and who gets left behind? We're entering the era of mechanically connected disasters where a tremor in one country becomes a synchronized catastrophe for 7. The Philippines' earthquake swarm isn't just a regional threat anymore. It's the preview of planetary-scale disasters that move faster than human response, and we're running out of time to build the systems that might save us.